Hi friends, in this video we are going to discuss system softwares. As you know, system softwares act as an interface for the underlying hardware system. Here we will discuss some important system software in detail. So, operating system. The diagram shows hardware, system software, application software. So, first of all, we will discuss operating system. Operating system is the lifeline of computer. You connect all the basic devices like CPU, monitor, keyboard and mouse. Plug in the power supply and switch it on, thinking you have everything in place. But the computer will not start or come to life unless it has an operating system installed in, because OS will do some functions. Keeps all hardware parts in a state of readiness to follow user instructions, coordinate between different devices, schedules multiple tasks as per priority, allocates resources to each task, enables computer to access network, enables users to access and use application software. Besides initial booting, these are some of the functions of an operating system are managing computer resources like hardware, software, shared resources, etc. Allocating resources, prevent error during software's use, control improper use of computers. One of the earliest operating system was MS-DOS, Microsoft Disk Operating System, developed by Microsoft for IBM PC. It was a command line interface. So, command line interface was that revolutionized the PC market. So, Disk Operating System was difficult to use because of its interface. The users need to remember instructions to do their tasks. To make computers more accessible and user-friendly, Microsoft developed graphical user interface based on OS called Windows, which transferred the way people use computers. So this is all about operating system. So next, we need to discuss assembler. What is this assembler? What is the need of assembler in computers? Assembler is a system software that converts assembly level programs to mission level programs. The following diagrams, if we see, assembly level program means source code, convert to assembler to mission level program. It is called object code. So these are the advantages provided by assembly level programming. Increases efficiency of the programmer as remembering mnemonics is easier. Productivity increases as number of errors decreases and hence debugging time. Programmer has access to hardware resources and hence has a flexibility in writing programs customized to the specific computer. So this is the functionality of assembler. So next, coming to interpreter. What is interpreter? The major advantages of assembly level language was its ability to optimize memory usage and hardware utilization. However, with technological advancements, computers had more memory and better hardware components. So ease of writing programs become more important than optimizing memory and other hardware resources. In addition, a need was felt to take programming out of a handful of trained scientists and computer programmers so that computers could be used in more areas. So this led to development of high-level language that were easy to understand due to reassemble of commands to English language. The system software used to translate high-level language source code into mission-level language object code line by line is called an interpreter. What is an interpreter? So the interpreter is the functionality do such a way that it is convert source code into mission level language object code. So an interpreter takes each line of code and converts it into mission code and stores it into an object file. The advantage of using an interpreter is that they are very easy to write and they do not require a large memory space. However, there is a major disadvantage in interpreters is interpreted programs take a long time in executing. To overcome these disadvantages, especially for large programs, compilers were used. So interpreters are line by line executing. So to overcome this, we have a compilers. System software that store the complete program, scan it, translate the complete program into object code, and then creates an executable code is called a compiler. On the face of it, compilers compare unfavorably with interpreters because they are more complex than interpreters. they need more memory space, they take more time in compiling source code. However, compiled programs execute very fast on computers. The following image shows the step-by-step process of how a source code is transformed into an executable code. Source code, pre-processing and lexical analysis phase, parsing phase, compiling phase, and finally generate object code and linking phase and executable code. Though there are steps in compiling source code into executable code. Pre-processing. In this stage, preprocessed instructions typically used by languages like C and C++ are interpreted, that is converted to assembly level language. Next phase, lexical analysis. So here all instructions are converted to lexical units like constants, variables, arithmetic symbols, etc. Next, parsing. Here all instructions are checked to see if they conform to grammar rules of the language. If there are errors, compiler will ask you to fix them before you can process. Next phase is compiling. At this stage, the source code is converted into object code. Linking. If there are any links to external files or libraries, address of their executable will be added to the program. Also, if the code needs to be rearranged for actual execution, they will be rearranged. The final output is the executable code that is ready to be executed. This is all about system softwares. We have discussed operating system, assembler, interpreter, compiler. So friends, next video we are going to discuss functions of operating system. Thank you.